Studies that compare treatments for chronic medical conditions such as headache could use the same subjects for each treatment. With a crossover design, each person crosses over from using one treatment to another during the study. One such study consists of a drug for treating migraine headaches in children. The study observed 30 children at 2 times when he or she had a migraine headache. The child received the drug at one time and a placebo at the other time. The order of treatment was randomized and the study was double-blind. So for each child, the response was whether the drug or placebo provided better pain relief. P denotes the proportion of children having better pain relief with the drug. In the population of children who suffered from these headaches, can you conclude that P is greater than 0.5? So more than half of the population would get better pain relief when using the drug. Of these 30 children, 22 had more pain relief with the drug, and 8 had more pain relief with placebo. All right. So the first thing we're going to want to do is write the null and alternative hypothesis. This is the thing that they're trying to show. Can you conclude that P is greater than 0.5? So I'm going to make that the claim. Now, because this doesn't involve equals, that would become HA. And then HO would be the opposite. The P would be less than equal to 0.5. Alright, so we've got our null and alternative. We have to determine if NP and NQ are big enough to use a z-test on this. So NP is going to be the number of trial participants, 30, times the hypothesized population proportion boundary there of 0.5. That's going to come out to 15. NQ will be 30 times 0.5 as well. So that is also 15. These are both greater than or equal to 5. Therefore, the assumptions of a z-test are met here. We can do a z-test on it. Let's draw the situation. So we're going to have our rejection region here. It's a one-tailed test. I can tell that because the alternative is saying that if P is high enough, we would reject the null. As long as P is low enough, we will not reject. So that makes our rejection region the right tail. Okay, we need to know what the cutoff boundary here is going to be. So we're going to actually look for a ZC. We wouldn't use T with these type of problems. When we have a proportion test, we use Z. Okay, next part of the question says, what is the rejection region for an alpha of 0.05? The alpha in the tail is 0.05. We have to find the ZC that goes along with that. Yeah, in the t-table, we want to look for one tail. This is one place to find it. There are other places to find it, but if we go to the t-table and go to one tail, some of these common alpha levels are given. Now, because we're doing a proportion test, we need a Z, not a T. So that means we're going to want to take this all the way down to the bottom. And that is where we get the 1.645 from for this problem. So that will be our ZC. Next, let's go to finding the test statistics. So for these types of problems, the test statistic is going to be given by z star equals p hat minus p over the square root pq over n. So we got to find our p hat. P hat's going to be x over n. Yeah, x is the number of successes in the study, so that would be 22. N is the sample size. 22 over 30. We could turn that into a decimal. Again. 22 out of 30 for p hat. P is 0.5. We'll divide by the square root of p times q divided by n. And we'll plug this into calculator. $2.56. Is the z star in the rejection region or no? So let's put the z star over here. It is in the rejection region. It's 2.56, which is greater than 1.65. So we will reject the null. And then what I'll do is I'll say that I just don't like the null. Just putting this in easy to understand terms. And I like the alternative then. And so I want to say something positive about the alternative, which is the claim. So when it comes to the claim, I will say at the alpha equals 0.05 significance level, there is enough evidence to support the claim that headache patients receive greater pain relief with the drug than placebo.